Hey everybody, I just wanted to make a quick video to highlight the difference between linear and exponential functions and also point out some of the similarities. Um, so on the left side of the slide, we have linear functions. This is kind of what we've been talking about all year with this y equals mx plus b format. Let me get my pen. Remember, m is our slope or rate of change, and B is our y-intercept or initial value. So that's kind of where the story starts. Initial value. Okay, and then we still have x as our input and y as our output. So that's actually something that's similar in the exponential functions. As you see here, though, this and all linear functions are going to have what we call a common difference, which means that their outputs, and I'm looking at this table here, right? Their outputs are either going to change by adding a certain amount each time. As you see here, we have plus 2, plus 2, plus 2, plus 2. Or you could see a linear function that subtracts by a same amount each time. So for instance, if I had 10, 8, 6, 4, 2, right? That would be subtracting by 2 each time. So that's what we call common difference. We either have addition or subtraction as we see the outputs change. And what this does is it gives us a straight line. You guys will see here, this amount stays constant. I'm adding or subtracting by the same amount each time, which is going to give me a constant slope. If you guys see that. We call that, it's a constant rate of change. The slope stays the same at every single point on that function, and that's because we're either adding or subtracting by the same amount each time. If I was subtracting by the same amount each time, that would actually give me a negative slope, and my line would look like this. Okay, but again, I'm still have a constant rate of change, still changing by the same amount each time. Okay. Over here, it's a little different. So now we actually have, this is going to be our initial value. I'm just going to say initial V. So A is the beginning of the function, or what we start with. B is kind of like the slope, but we don't call it slope anymore. This is sometimes called a base. We're going to be even more specific and call it the common ratio. So if you guys see here, instead of adding or subtracting each time with an exponential function, we're actually multiplying or dividing. All right, so if you see and with these outputs in this table, we actually go 1 times 2, 2 times 2, 4 times 2, 8 times 2. Right, we're using multiplication. And I'm actually going to get another color because I want you to see this. What happens here is that we're actually not adding by the same amount each time. So this was a plus 1. This is now a plus 2. This is now a plus 4. This is now a plus 8. Okay, so over here, we were adding by the same amount each time. That's not happening in an exponential function. So while we are multiplying or dividing by the same amount each time, if you look at either at the addition or subtraction, it's not the same amount. And this is why we get this curve. All right, so if you look at the graph here, if I look at the slope down at the very bottom, it looks different than the slope here, which looks different than this slope, different than this slope, much different than this slope, very different than this slope, right? Slope's not the same. And that's because of this. We're not adding or subtracting by the same amount each time. We don't have a constant rate of change. Instead, we have what's called a common ratio, and this is where you're going to see multiplication or division. Just to highlight a couple, and if this is confusing, don't worry. We're going to be talking about this for many, many lessons. This is just kind of your intro to these differences. But I do want to then still highlight there are always similarities still. We still have inputs and outputs, right? Inputs, outputs. Here they're just a little different, right? So my input in an exponential function is actually the exponent. So you see it's raising b to the power of x. So this is going to be my input, and I still have an output of y. Table still looks the same, still have my inputs, still have my outputs. My graphs, for both of my graphs, my inputs are on the x-axis. Both of the graphs, the outputs are on the y-axis. So again, we're going to be going through this for many, many lessons, but I just wanted to highlight the slide so you guys feel comfortable doing the homework and answering the exit ticket.